few seconds before we start. Good evening, ladies and gentlemen, and welcome to our January 2016 public lecture series. I have the joyous pleasure of being your host, Dr. Frank Summers from the Office of Public Outreach here at Space Telescope. On your way in, I actually put them both sides tonight. We have our lithographs, and somebody saw there was a galaxy collision image released by Hubble, the European branch of Hubble today. And so I said, all right, well, let's go get you another image of interacting galaxies. These ones are called ARP 273, which means they're the 273rd entry in the ARP catalog of peculiar galaxies. You want to know more about it? Flip right over and we have some information on the back. If you didn't get one on your way in, please pick one up on the way out. Tonight, our talk is about White House Astronomy Night, something that hasn't happened for 6 years now. Yeah, this is so it's a not very common event, and we had 3 people here to tell you all about it. Upcoming next month, we'll be talking about the southern skies, astronomy in Chile. There are more wonderful telescopes in Chile than you can shake a stick at. It's an amazing place to do astronomy, and I'm actually really interested to hear all about it from you, Bobo. In March, John Debes is back, and he's giving one of his interestingly named talks. This one, Planetary Tales from the Stellar Crypt. Exoplanets surviving the death of their host star. So look forward to a gruesome stellar planetary death formation type talk there. Actually, I don't think he can make it really gruesome, but you know, John is inventive, at least with his titles. And in April, Rachel Austin will be talking about why we need to understand stars to find the next Earth. We are in such an exciting period in searching for planets out in the universe, but we do need to understand a few things in advance, and Rachel will go through that. If you would like more details about these talks, reminders of when they are, you can go to our webpage. We have this Hubble site Go link, or basically if you just do a search for Hubble Public Talks, you should end up at this web page here. Okay, it gives you the list of the upcoming lectures. Importantly, it gives you the link to the webcast, okay? We have been webcasting these for a decade now, almost a full decade. No, actually, it's more than a decade. It'll be 11 years next April, all right, that we have been webcasting. So there's a lot of cool goodness out there. Using this link down here, you can go back to the archive and take a look at all of that stuff. Email, if you would like to get the announcements. We send out 1 or 2 announcements a month reminding you of these lectures. You sign up at this maillist.stsci.edu. It's called Public Lecture Announce. Pretty straightforward, right? Provide your email address. You will not get any spam. At least there's been no spam so far. If you would instead like to contact us, you can send your emails to publiclecture@stsci.edu, provide comments or questions, or if you find maillist.stsci.edu too hard to go to and sign up yourselves, just send me an email at publiclecture@stsci.edu. It's very easy for me to add you to our mailing list. Social media. If you're on social media, we are on Facebook. We're on 2, not 1, but 2 Twitter accounts, Google Plus and Pinterest. I have a blog on Hubble site. I'm on Facebook, I'm on Google Plus, and I'm also on Twitter, although I'm not the most active person on social media. So you get what you pay for. It's free, right? Okay. After the talk tonight, I got the email from Duncan. Duncan, are you here? Yes, Duncan is in the back row there. Duncan, the amazing Duncan, will take you across the street to the Maryland Space Grant Observatory. It is freezing cold tonight, but that often makes for the best seeing, okay? It's one of the horrors of astronomy that the coldest nights are often the best nights for seeing. So bundle up warm. I wish we were selling hot chocolate in the lobby. Well, Duncan probably wouldn't let you bring hot chocolate into the dome anyways. But anyways, so Duncan, where are you going to be? Down here on my right? Yeah. Okay, down here on my right after the lecture. If I forget to go corral people, remind me as you usually do. Okay. Now we get to my news summary, news from the universe for January 2016. Our first story tonight, an astronomical prophecy fulfilled. Now, you've seen many movies that have astronomical prophecies, and they're usually about things like planetary alignments, and they're just such crap. Because we all remember the amazing turbulence and things that didn't happen in 2012, which were supposed to cause by planetary alignments. And there's just so many movies that talk about astronomy changing things. Well, we have an astronomical prophecy that has finally been fulfilled. And it doesn't take place here on Earth. It takes place in this galaxy cluster. Now, this galaxy cluster goes by the name MAX J1149.6 plus 2223. Which of course is its catalog name. Except it's also known as MAX J1149.5 plus 2223. I actually noticed that we used both of those in 2 different press releases. And Vanessa's shaking her head at me like going, yes, we did that. Why? We've got 0.5 in one press release and 0.6 in another. So if it changes over the course of my slides, that's why. All right. So this is a huge cluster of galaxies. It is so massive, it has gravitational lensing happening on. The mass of the galaxy cluster is so great that it actually warps space. So here is a visualization. We got this distant galaxy up here in the upper left, okay? And as the light from this distant galaxy travels towards Hubble in the lower right, it passes by this galaxy cluster, which the warped space bends the path of light, all right, so that the galaxy cluster acts like a lens, okay? So when you have that much mass concentrated, you can actually act like a glass lens and change the path of light. So what happened in this case is that in a very distant galaxy, there was a supernova, a star that exploded and became extremely bright. This one was nicknamed Refstal, named after some guy whose name is Refstal. I don't know anything about him. But anyway, so supernova Refstal occurred in a galaxy far, far away. All right, and its light came through the galaxy cluster. Now, it didn't get bent by the cluster, but it got bent by this one galaxy here, okay? So that one galaxy, the supernova light came through it, and we got 4 images of that supernova, okay? So let me put the circles around them. You see those 4 yellow dots? That's 4 images of the supernova that came through around the mass of this one galaxy. All right, so we had the lensing set up such that the supernova in the distant galaxy came past this one galaxy in the cluster, and we got 4 different images of it. However, this was announced back in like March of this year, okay? So this is old news. However, the light will also pass through the galaxy cluster itself. So they analyzed the mass distribution in the galaxy cluster, and they figured out that it should also have passed this direction, and it should have passed this direction. The light from the supernova will pass 3 different ways through the galaxy cluster. Now, the prediction was that this passed through about a decade or so ago, about 15 years ago. So we weren't going to be able to see it. But this pathway through the center of the cluster was actually going to take place in the next few years after we observed this. And so they refined their models and they refined their models, right, and they're able to predict that they would see the light of a supernova right before it appears. First time ever. All right, so we're able to say astronomers get a once-in-a-lifetime opportunity to predict a supernova. Okay, we know that that light is going to come through. Well, depending upon how good our mass models for this galaxy cluster are, right? So we studied this portion of that galaxy cluster, all right? Well, unfortunately, with Hubble, you can't study it. You can't just sort of stare there and go, is anything happening yet? Nope. Anything happening yet? Nope. You know, it's not like the can you hear me now guy, right? So what we had to do is they had to schedule observations at a cadence such that they'd likely to be able to catch it. So they looked at that portion of the galaxy, and on October 30th, they saw nothing. But when they looked on December 11th, see that tiny dot? That's the advance of science. Tiny dots are the advance of science, okay? New science! Science happens with tiny dots. That is the supernova reappearing, okay? So we were able to predict the appearance of a supernova. According to the paper that I read, the supernova will get to its brightest in the next over the next 90 days. So this was discovered in December, January, February, somewhere around February, March. It should be at its brightest. So they will be watching it with as much Hubble time as they can get in order to follow the brightening of that supernova, predicted to pass through the gravitational mass of this galaxy cluster. An astronomical prophecy that has finally been fulfilled, okay? All right, our second story. Hubble sees the Force awakening in a newborn star. Now, how many people are regulars here? You guys have been here. I usually come up with a silly title for all of my stories, right? I try and come up with something creative. This is not my title. This is the actual title we used for our press release. It's right here, you know? Hubble sees the Force awakening in a newborn star. What we were trying to do, we of course were trying to tie in to the opening of Star Wars: The Force Awakens. So, as you know, Star Wars takes place a long time ago in a galaxy far, far away. Our story doesn't. Our story takes place not so long ago in a galaxy not far away, okay? This story takes place, in fact, in our own galaxy, the Milky Way, in the constellation of Orion, okay? So here's the constellation of Orion, here's Orion's belt, and here's the sword dangling down from the belt. We're not going to hit Orion below the belt, we're actually going to go above the belt into this region here. So if I zoom in on that, you can see the stars of the belt, Alnitak, Alnilam, and Mintaka. All right, and so here's the Horsehead Nebula, and here's the Flame Nebula. Gorgeous stuff. That's where star formation's going on. We're paying no attention to that. We're going up to this dark stuff up here. All right, in this region, it's called Orion Molecular Cloud 2. We zoom in on that, and you can see that there's some bright stuff going on in here. We're going to ignore that because that's not what we're interested in. Instead, down here inside these dark clouds is where we're headed towards something called Herbig-Haro Object 24, HH24. And we zoom in almost to the penultimate time. This is an image released by the Gemini Observatory, Hawaii, where we've got HH24 up here and another region down here that we nicknamed Australia because it looks kind of like Australia, and it is down under. Okay? And so finally we come to the Hubble image of the Hubble image of celestial lightsabers. This is how we tie into Star Wars: The Force Awakens. We have a Herbig-Haro object, okay? What is that? That is a newborn star, a brand new star right in here. And as part of the star formation process, it shoots out these energetic jets. Right? There's a disk of material swirling onto the star. There are jets that spew out in opposite directions from that jet. And it looks like Darth Maul's double-bladed lightsaber from The Phantom Menace, okay? And just to let you know, we didn't leave it just to the title. We talk about this in the center of the image, partially obscured by a dark Jedi-like cloak of dusk, a newborn star shoots twin jets out into space. The folks in Europe went even further than that. They talk about the star is mostly concerned with feeding its Jabba-like appetite. Once nourished, the star awakens and jets of energized gas whirl out in opposite directions. The force is strong with these twin jets. The effect on the environment demonstrates the true power of the dark side with a blast stronger than one from a fully armed and operational Death Star battle station. I'm not the silliest guy in astronomy, okay? So this was really cool. We were able to think. But what's really nice about this is it's not just these jets here, okay? You can see this sort of vortex type thing here. There's another jet spewing out through here that has created this sort of cylindrical passage through it. That's really cool. If you see this stuff over here, there's another jet going off over here. There are a bunch of these jets going on in here. This is a very vibrant and energetic region. Newborn stars actually reshape the environment in which they form. And it's kind of cool. I thought the best press release, press reaction to this came from the Washington Post in their blog. They said, this star totally does look like a lightsaber, even though we're sick of Star Wars already. We put this out Wednesday, right? Or Thursday? I think we put it out Wednesday, and Star Wars opened on Thursday. And there was so much Star Wars ties in all over the place. But Rachel Feldman, in her Speaking of Science blog, says, "Ugh, I'm so sick of all the Star Wars ties in. Not everything has to be about The Force Awakens, but you win. I admit it, that star does look a lot like a lightsaber." All right. All right.
Well, what causes these jets to occur? I mean, they seem to occur all over the place.
Okay.
And with
I'm not an expert in it, but what I understand, in order to get the collimation, what you end up doing is you've got this spinning disk of material, okay? You're also going to drag magnetic fields with that, and the magnetic fields can spew can very much align things into the jets, and material can get flung off along those magnetic field lines, all right?
Is that the same as a quasar then?
Quasar is much, much larger. Quasars are supermassive black holes at the centers of galaxies. This is just a forming star. This would be, a solar mass or less here. So versus a quasar, which would be a supermassive black hole, millions to billions of solar masses. So the principle is the same in terms of high energy spin up and then spew off perpendicular to the jet, but the scale and energy scales are much, much, much different. Okay. And of course, because we have a cool image, we had to make a movie. So our group that I get to work in took the image, dissected it, pulled it into 3 dimensions, just a little bit, because it's actually a kind of small image. It's only 1,000 pixels wide. And then we created our own little movie called Celestial Lightsabers. So this gives you the context in 2D. We start out with a 2-dimensional zoom into the Orion constellation of Orion, above the belt into the Orion Molecular Cloud 2, and then at the bottom of the OMC2 we see HH24 appear. At this point we then drop into 3D, so you'll see the stars move off in 3 dimensions, and we pull in, and now we finally get down to the scale of the Hubble image, zooming in and seeing a rough 3-dimensional structure for the jet. And that's how NASA does Star Wars: The Force Awakens. Okay, our featured speakers tonight. We actually get 3 of them because all 3 of them were invited to the White House. These are our hallowed people. On the left, we have Vanessa Thomas. She is in the Office of Public Outreach. I don't know what your title is. She's just a fantastic science writer and all-around astronomically knowledgeable person. You don't pigeonhole this lady, okay? Because she can do lots and lots of different things in the Office of Public Outreach, and I love working with her. In the center, we have Max Mutchler. Max is a self-described creature of STScI because he has been here for 25 years, okay? He has been here, you got here just like a week before Hubble launched, if I remember?
Yes, 2 weeks, yeah.
2 weeks before Hubble launched, he arrived, and we haven't been able to get rid of him yet. He works in the RIA, Research and Instrument Analyst Division, working on the instruments of the telescope. On the right, we have Rosa Diaz, who has been in the building since 1997, right? But there's something like your job started at the 1999 or something like that. Anyways, she's also a long-term member here. We have a lot of long-term members here at Space Telescope, okay? People, they tend to like working here. We have a nice place. She is an MSS, which was Missions Science System Science, okay? And has been around. And all 3 of them are also amateur astronomers because they actually operate telescopes. I was never an amateur astronomer. I used binoculars when I was a kid, but that was as far as I got. I didn't work. I did a little work with telescopes in college. These guys actually know what they're doing. And so, ladies and gentlemen, Vanessa, Max, and Rosa, White House Astronomy. Give them a hand.
All right, so we're going to have a little division of labor since the three of us got to go. We're going to take turns presenting some slides and just sharing a very special night with you and kind of chiming in on each other's points. You know, when you're a kid growing up in Wisconsin, laying on your back looking up at the stars, not only do you never imagine that your interest might lead to you working on the Hubble Space Telescope for 25 years, but you also don't imagine that someday you'll be doing it on the south lawn of the White House, and not once but twice. You may have heard, I don't know, we were there, so I don't know if it was really big news, but I mean, did you remember hearing about this on the news at all back in October, the Astronomy Night at the White House? So we were fortunate to go, and let's see. All right. Do I need to turn this on, Thomas?
You need to touch the slide, I think.
Well, it was working earlier.
Light working?
The laser, or?
Looks like it's on.
Yeah, it is on.
Sometimes you have to touch the slide.
I can go stand over there.
I will unplug it and replug it and see if that changes it.
Why don't I just come over there?
I think you're gonna. Well, actually.
There, click in there.
Oh, there you go. Okay.
That was waking up.
Good job. Okay, so it was back in October 19th, and the three of us got to go. But in our division of labor here, I'm actually going to talk about stuff that has occurred before this. This is, like I mentioned, this is not the first time there's been a star party at the White House. Vanessa and I got to go to one, the first one. It was part of the inaugural year for President Obama in 2009, and you can see him looking through a telescope there, right from the south side of the White House there. And here we are setting up, again, this is 2009 on the south lawn, just bring your own, you know, you can see kind of modest, or just our own personal telescopes, you know, for just a real star party, just like you'd have in anybody's backyard, but obviously this is a pretty special backyard. So these are, you know, for those of you who use telescopes, I mean, you can see these, I think they're both Dobsonian telescopes. I also had my little AstroScan, which are very common in the schools because they're nearly indestructible, the little red ball there on the table. And you can see how everybody else brought their own assorted equipment. So after setting up during the day, you know, different groups of kids were coming through, lots of celebrities. It was kind of like fantasy camp for space geeks, basically. There was not only, I mean, the focus was on kids. You probably heard a lot of these events that, especially I think Michelle Obama's been doing with, you know, different things, gardening, you know, science, things like that. And I believe this one was kind of inspired by her. And so it was really great to be able to share, you know, the experience of looking through a telescope with all these kids. Oops. But it wasn't just kids. It was, like I said, kind of fantasy camp. There was lots of VIPs, senators, you know, former astronauts. And the highlight for me was getting to hang out with Buzz Aldrin and looking at Jupiter and the moon with the guy who's actually walked on the moon. For any kids in the audience, Buzz Aldrin is the original Buzz Lightyear. Second person to walk on the moon. So that was pretty special. I almost forgot that there was another event for Obama's second inauguration in 2013. It wasn't quite as exciting as being on the south lawn of the White House. And in fact, the president wasn't there at all. But it was a part of the inaugural, and Vanessa and I did get to participate in that as well. It was at a planetarium just across the river, across the Potomac in Arlington. By this planetarium associated with the high school, I guess, and you can see the contingent there, including me and Vanessa and several other members of our Office of Public Outreach that supported this event as well. So, except that it was, you know, it wasn't on the south lawn of the White House, and the president did not appear, but it had basically a lot of the other same elements. A lot of, you know, there was astronauts there. There's me with Mike Massimino, who twice serviced the Hubble Space Telescope. And I don't know if you remember the Mohawk guy from the JPL's Mars rover fame. He was there. And you can see just a whole bunch of people from the area. Again, a bunch of people just setting up telescopes affiliated with NASA, and a whole bunch of people coming out. It was a rather cold and blustery night, as you can kind of see. As Frank said, that's really good for astronomy, actually. In fact, one thing that's remarkable about all three of these events I don't think any one of them was going to get rescheduled because of the weather. And by just incredible luck, all three of them had just perfectly cool, crisp, ideal conditions. So it actually had me wondering if there was some way that the government has a way to arrange for that, that we're not aware of. I don't know. All right, so I'm going to pass it over to Rosa now to talk a little bit more about the event we actually went to in October.
Well, as he was saying, this is the first time that I went to this event, and actually I found it really, it was very exciting for me to participate because I like to motivate young people to get involved in the STEM field, so being able to do that at the White House was really a great thing for me. And this was the second ever Astronomy Night at the White House, and the president, the White House had the mission to motivate and inspire the boys and girls to get involved in the STEM fields. And in this Astronomy Night, the way to do it is through science and space, to engage them to activities that had to do with science and space. But this event actually didn't want to limit it only to the White House. In particular for the White House, there were students, teachers, scientists, astronomers, engineers, and even space enthusiasts that participated in this event. And what we had was observation in different telescopes, so kids were exposed to different technologies that you could use. But also there were hand-on activities, very cool hand-on activities, like kids were able to experiment with new technologies like Sphero. We have some of the slides that later on we are going to present on what we took from the band. New technologies like the SpaceX, what is the name of the Draco booster, the 3D printed new booster for the SpaceX missions. So I think this was very exciting for the kids to be involved in these activities, but also the president didn't want to limit it, as I said, to the White House, but it also invited the schools across the country, and also national parks and other institutions to participate these same days in the same team, the same kind of activities that would engage and motivate kids. And more than 35 states participated with more than 80 different events. As you can see, the stars, even in Puerto Rico, the Grand Canyon National Park had events, and even in Europe, there is a NATO base, a school in a NATO base also participated in this event. So one motivation also is just to show to the teachers and everybody involved the way that they can motivate, the tools that they can use to motivate the kids to get involved in the STEM science. So as Max was saying, I mean, it was a very exciting experience for us to be there. And actually, Vanessa, and this is the invitation that we got for the Astronomy Night. And Vanessa is going to go to the different photos that we took and other people that we were involved with took for this event. As we said, I mean, we were honored to be able to be part of this as a group of the NASA group that went to help with the event. And I think that it helps that we were able to help with the telescopes. So Vanessa is going to go through the slides, and as Max said, we are going to chime in with some comments along the way.
Thanks. So yeah, as Rossi said, I'm going to just lead you through the day and what we experienced throughout the day. But just to start out with, as you said, this was the formal invitation that we got once we were all approved to attend after getting our background checks. So that morning, the event didn't start till like 7 p.m., but we had to show up starting at 9 a.m. We met at NASA headquarters with some other NASA folks. So you'll see the three of us, and the rest of the team there is from NASA. We were all telescope operators. Michelle Fowler in the back, she organized our little group and coordinated everything for us. But we met at NASA headquarters in DC in the morning and packed up our telescopes. And our telescopes and equipment all had to be at the White House by 11 a.m. so they could do their security checks to make sure there was nothing bad in our equipment. And then we were supposed to show up at noon, so we had this quick lunch near the White House beforehand. And then we did show up right at noon. We were right on time, but of course it's a hurry up and wait kind of day. So we had to wait for maybe 15 or 20 minutes before they actually started checking us in. But we had to show our IDs before they let us in the gate. And you can see me coming through the gate there. I was on the list, so I did my little happy dance. And then once you got through that gate, these two ladies in the front, they checked your ID a second time. And then once you got past them, there was a third checkpoint where you had to show your ID yet again. And that's when we actually had to go through the metal detectors and the X-ray machines and things like that to make sure we weren't smuggling anything in. And then once you made it through all those 3 checkpoints, we actually did get to go into the White House. This is the east entrance. And this is the east lobby. This is what it looks like from the inside. You can see a couple of the other exhibitors bringing their equipment in. They had to lug it through the White House. But we were able to arrange to have our telescopes brought in by a van, luckily, so we didn't have to carry our equipment in. Then we got a little briefing about where we were going to set up, and we got instructions and maps of the White House lawn to show us where we were all assigned. And then once we got those instructions, we went out here, which is the Jacqueline Kennedy Gardens, and we actually were told to hold here for a little while. Because Jay Farrow of Saturday Night Live was actually doing a shoot on the South Lawn at the time, and they hadn't finished yet, so we had to wait for them to wrap up before we could go start setting up our equipment. So we hung out here for maybe 5 or 10 minutes, and of course took the opportunity to take some photos. And there's Rossi there, another picture of the gardens. And of course, once we got on the South Lawn here, we had to get pictures of us on the White House lawn. I mean, just have to. So here was the map of the whole setup. At the top there, where it says executive residence, that's the White House. They had chairs set up for the president's address later that evening. These blue rectangles were where the exhibits were set up. This was a portable planetarium, and then they had 4 separate sections of telescopes, and each of us was assigned to one of these 4 groups, and each of those 4 groups was assigned what objects in the sky that we were going to look at. And then you can see
actually in the sides next to the White House, there were other exhibitions too.
Yes, there were. Yeah, you're right. There's a brief list we'll go through, show you pictures of the exhibits later. There's a planetarium. If you've never seen what a portable planetarium looks like, that's what it looks like. It's inflatable. You can go inside and they project the stars on the inside of that dome. Here's us setting up. That's Max there behind the red telescope. That's his telescope. There's Rossi setting up our Office of Public Outreach telescope.
Yeah, actually, Max and Vanessa, they have their own telescopes. I made my own telescope when I was younger, but then I gifted it. So I had to bring the one from the Institute, but which is a big telescope too. So I was lucky to have that one.
Yeah, it was bigger than our personal telescopes. So this is what it looks like once it's set up. And just to give a little bit of a story here, Rossi was assigned this group over here on this side of the lawn, but ended up moving over to this side. And in the process, after we'd set it up, you decided to move and got permission to move over because you wanted to observe Andromeda Galaxy instead of whatever was assigned over there. And in the process, we put it on a cart instead of disassembling it and reassembling it. We put it on a cart, and while we were moving it just that short distance, 2 of the screws at the bottom fell out that were holding the mirror. And if the third one fell out, I don't know what would have happened, but
we actually didn't know. We didn't know what those screws were coming from.
We saw the screws come out.
I mean, we saw them falling, but we didn't connect it with the mirror itself.
Yeah.
So we were lucky that the last one didn't come off.
Yeah. So the next hour or 45 minutes, whatever we had, we were like frantically trying to rescrew and realign the mirror, but.
And one of the things Vanessa was saying, each of the sections were assigned to observe one object, and that was a way for them to organize people that were coming in groups. Mm-hmm. If we were observing different objects in the same area, if there were too many of the groups coming, they would be rushing to try to observe all of them. If we were observing the same object, and if they didn't have time to go to one of the telescopes, then they wouldn't be disappointed because it was basically the same object. But also an important thing, it is to observe the same object with different technologies, so people will know what a different telescope will show you, the size. Even there were some binoculars, but I don't know where the binoculars were, just to show people that what they can do just with simple binoculars, what they can observe. So basically the groups had 2 purposes, but also to show the different technologies.
So another little problem we had was this fountain. We were set up right next to the fountain. That's where we were told to set up, and we couldn't move very far from the fountain because, as you can see, there are trees, and you don't want to be right next to the trees because then you can't see the sky because the trees are in the way. So we were between the trees and the fountain, and the fountain was actually spraying us a little bit, and that's not good for observing the sky with a telescope. You don't want water coming into your telescope. So luckily there were people coming around asking us if we needed anything, while we were setting up, and we asked, "Can you please turn on the fountain or turn it off?" And they said, "Well, we'll see what we can do." Here's a shot from the other side with my telescope. And luckily, you can see they did turn it down.
Yeah, they said that they could not turn it off. That was impossible. Mm-hmm. They just put it lower, but that was it. So
thankfully, we weren't sprayed with water all night in that chilly, cold night. Another neat thing about this photo was this telescope in the foreground. Somebody else who came from Arizona to be a telescope operator actually decorated his telescope for the event itself. So once we were set up, we actually left for a couple hours to go relax and get some dinner. And when we came back, this was a shot I took from outside the gate of the setup. So you can see these were the seats set up for the address, and these were where the press was going to set up. You can see some of the exhibits set up here, and our telescopes were set up back here near the fountain. But I just thought it was kind of a neat view of, you could actually see the whole setup from the outside. And then, as you can see, and as Max said earlier, we couldn't have asked for a better night. It was perfectly clear. And the moon was up. That was one of our targets for the night. And they had a nice little surprise that they didn't have the first time. I don't remember there being a band there, but they were playing some astronomy-themed music. I remember Moon Dance from Van Morrison was one of the songs that they were playing. And they had hot apple cider for us as well. So it kind of felt like you were at a little private party at the White House.
Yeah, because that night was kind of chilly. It was
cold. Yeah,
it was cold. So we appreciated that.
Yeah. And the president did meet with some of the people who were invited. Did you want to talk about
Yeah,
this?
actually, I mean, we were not the lucky ones that had the opportunity to meet with the president in advance. I mean, but they invited people, kids that had participated in different events. And for example, the girl in the dress, she's Phoebe Kinselman, which actually participated in a space camp in NASA Johnson Space Center. Then
Pranav is Sivakumar. I'm sure that I'm not pronouncing his name properly. Is the guy in the sweater, and actually he was one of the global finalists in a Google Science Fair. I believe, but I am not 100% sure, that the girl in the stripes is part of the RCS rocketing champions from Roosevelt, Alabama, that basically that won the international competition launching X. And actually, the president in the speech, he talks about that. So I think that it was very neat for those kids that have participated in those events, that have worked hard in those things, that they were able to meet with the president. So maybe next time we will be able to do that.
I guess while we're talking about interacting with the president, neither in 2009 or this time did any of us interact directly with the president, although I can share an interesting story from the first time. So this time, as you'll see, the president came out, gave a speech, shook a few hands in the front row, and then went back in the White House. There was much more interaction with the first family in 2009. The president gave a speech, went back in, but then after about an hour, the whole first family came out and was walking around. And but there were several stations to go to, and obviously they didn't go to all of them. But it was surprisingly dark. Actually, in 2009, it was much darker. It was actually pretty eerie to be at the White House with it being so dim and seeing the White House so dimly lit. And when they were moving around, you can imagine there's quite an entourage around the first family. Most notably, a whole team of Secret Service, shoulder to shoulder in a ring, right? So there's this dark mob moving through the crowd that you knew had to be the first family, right? And it was you could kind of see it moving around in the dark. And again, it was remarkably dark. I mean, you really couldn't see people that well. And all of a sudden, the big mob started moving towards me, and I'm like, oh, cool, I'm about to have an interaction with the first family. And then my colleague right next to me from Arizona with the decorated telescope says, I've got Jupiter over here. And the mob moves towards her. And I'm like a deer in the headlights, right? Now, of course, we're all looking at Jupiter, so that was kind of a phony pitch, right? But, she had the force, or she had the, she didn't freeze in the headlights like I did. And so the first family goes right next to me. And I had, instead of getting to interact with them, I get a Secret Service guy right in my face. And so they were right there, and I could hear everything they were saying and see everything they were doing. And at one point, I wanted to take a picture, of course. I noticed nobody was taking a picture, because in the circle. But I was a little nervous about reaching into my jacket at this moment, right? And I've got a Secret Service guy right in my face. So I say, can I take a picture, and just reach in my jacket? And I thought he was going to say no. But he said, yeah, go for it. So I just pick up, and I feel bad because I forgot to include this photo in here. So I just take out my iPhone, and I can't see what I'm shooting at, so I'm just kind of going like this, hoping I get a good shot. And I did get some really good shots of the first family looking through it. Again, I apologize. I just realized I forgot to include that in here. But so that's as close as I got.
But as Max said, the president did come out and gave a speech to us about the importance of astronomy and science in education, which was a great speech, and we'll show it at the end. And this was the crowd. This was much more formal than in 2009. In 2009, he gave a speech, but we were just kind of all gathered around him. This time we had seats, and we actually had assigned seats, and we telescope operators were the least important VIPs, I guess, because we were back here. This is Max and me, and Rosa. Rosie was to my left there. But yeah, this was the last row.
We were hiding, but we were very important for sure.
And this spacesuit came from the Air and Space Museum, so he was there the whole time next to the president while he was giving his speech. And there was also a telescope again this year for him to look through, which also came from the Air and Space Museum, by the way. One cool thing this year was that they had a high school student come up and talk to the president about the telescope and what he was about to see in the telescope. So this is a high school student from Brooklyn who's originally from Paraguay, and she did a fantastic job just explaining the telescope and what the president was about to see, which was the moon. Which was an excellent choice because everybody loves seeing the moon, in my personal opinion, looking at the telescope. Even now, I've seen it hundreds of times, and I still love looking at it. It always makes me say, wow, when I see it in the telescope. So there were other, after the speech, the president did interact with a few people, but not everyone. He didn't stick around very long, but here's some of the people who were there. You may have heard of Ahmed Mohammed. He made a clock and brought it to school and was arrested because the teachers thought it was a bomb. But he was invited to the White House, and this is when he came to the White House, was during the White House Astronomy Night. So he got to see the president and also meet an astronaut. And I'm sure he talked to several other people as well. These are the 4 astronauts who are going to be flying on the commercially built spacecraft. They're called the Commercial Crew astronauts. So they were there. And if anybody's fan of the Mythbusters TV show, the Mythbusters, Jamie and Adam were there. And they did talks throughout the night with various people. This is the NASA administrator here, and a physicist, astrophysicist. They spoke to them for a few minutes, and then...
And also you can find all these interviews in YouTube. So if you are interested in seeing them, you can Google them.
Yeah, the White House posted video of the night and these interviews. Mae Jemison, she was at both 2009 and this one in 2015. She's the first African-American astronaut, female African-American astronaut in space. And this is John Grunsfeld. He's chief Hubble hugger. He's been to the Hubble Space Telescope 3 times on 3 different servicing missions, and he's now the associate administrator for the Science Mission Directorate at NASA. But he was there as well, talking about astronaut equipment to the kids and other attendees.
And actually, this exhibit was a NASA exhibit, and what you see the kid touching in there is a moon rock. So they had different moon rocks in there, as well as Mars rocks and some meteorites that the kids could look, and he's showing the glove. So that was one of the exhibits from NASA.
And I'm sure a few of you have heard about the James Webb Space Telescope. That's the next big telescope that NASA's building. The mirrors are segmented, so this is one of 18 segments. I mean, this is not an actual segment, but this is the size and shape and what it looks like. There'll be 18 of these on the James Webb Space Telescope main mirror, and that's actually being built at Goddard Space Flight Center in Maryland right now. They have all but 6 in place right now, but Ball Aerospace worked on the mirrors, so they were there to talk about the James Webb Space Telescope mirror. And you may have heard about the lettuce that was grown on the International Space Station recently, so those people were there to talk about how that lettuce was grown. And Boeing is one of the companies that's building one of the commercial spacecraft for astronauts to fly on in the future. So this is a model of their Starliner.
And actually, this Starliner, they use it for testing the aerodynamic characteristics of this the Starliner in advanced wind tunnel. So this is the model they use. It's an actual one.
NASA has a few different space telescopes that study the sun, so a couple of those were represented there. It's an exhibit.
And this is a part of the science that basically introduced the kids in what we do to understand the sun, and also space weather. You see the image of the sun that was taken by the Solar Dynamic Observatory in there, I mean, different wavelengths, but also you see there a model of a satellite that basically traces the flow of plasma and energy between the sun and the earth. So it's what we call the space weather. So that's a model of IRIS, is Explorer.
And I didn't get to check this out, but I wish I had. This was a virtual reality get-up that you could actually simulate walking on Mars.
Yes, and actually I didn't do it this time. I did it in another event, and if you have issues with motion sickness, I don't recommend this because you really get very dizzy. But I mean, they were cool showing this thing, and actually Oculus Rift technology, this one is going to be released 2016. Actually today, I think it is when you can start placing orders for this new technology, which is very cool also for teaching kids about science. I mean, we need to kind of develop the imagery that you need for this, but the Mars travel, it's very cool.
And SpaceX is another company that's working on commercial crew spacecraft.
And actually, this is 3D printed. So basically, they have developed the technology that they can print. This is a thruster for the space, the Draco, the Crew Draco spacecraft. And that's a big advance, really, in technology, because they can print this in 2 days, when before producing something like that will take months. So that's very cool.
And the astronauts did walk around and talk to people. They talked to some of the exhibitors and the kids who were there. But we were there for the telescopes. So here's some of the telescopes that were set up. And Max, I don't know if you want to talk about who visited your telescope.
Yeah, so that's my telescope. Again, that's Mae Jemison, former astronaut. And on the right is the young woman who was up there with President Obama, kind of instructing him. You'll see her prominently in the video at the end.
And at the end of the night, the Mythbusters and Bill Nye, the science guy, who was also there, they did a little Q&A with the audience for maybe 20, 30 minutes, which was really nice. They got to interact, and I snapped this picture of Bill Nye doing a bow tie demonstration, because he's famous for his bow ties. And I believe Adam asked him if he could demonstrate how you tie a bow tie, so that's what he's doing there.
And actually, Max took those pictures, and I must accept that I got important people coming to the telescope, but I just I was excited with the telescope, and I mean, I didn't snap any pictures, but I mean, we had not only kids, but also the adults coming, very excited to see what we were observing.
Yeah, it was kind of interesting. You didn't know who was visiting your telescope, but you knew they were probably somebody important. So that was pretty much the end of the night. We wrapped up. We had to take down our equipment. What the lawn looked like. Once we took down our equipment, you could still see the moon up over the fountain there. View of the White House at night. So at this point,
you can start she's going to show this speech of the president, but one fun thing, I mean, when we finished, we had to wait a long time for the van from NASA to come to pick us up, because they had to check. They had to go through security. That meant to check everything. And I mean, we really had to wait a long time, and they were asking us to leave because the president wanted to go to sleep. And the lights were on, and we said, well, we want to sleep too. And when we were leaving, we had to walk through where the Secret Service told us, because at one point someone said, oh, we will go this way, and we'll say, no, you go this way. Okay.
all we wanted to do was get out, and we couldn't get out because we tried to go one way, and they said, nope, don't go that way. But finally, somebody let us out.
I kept thinking we were going to look up and see the president looking at us from a window, like on the second floor, waiting for us to get off his lawn.
Hello, everybody. Yay. Well, everybody have a seat. Welcome to the White House. I love Astronomy Night. And we've got a very clear night to enjoy Astronomy Night. This is some of the most fun that I have on this job. They never let me tinker with the telescopes. They don't let me hold the moon rocks when you guys aren't around. Michelle is dying to know how they grow lettuce on the International Space Station. But when you guys come, I get to have some fun. And we've got some space buffs here tonight. We have a number of members of Congress, including former astronaut Senator Bill Nelson from the great state of Florida. My science advisor, John Holdren, is here. Where is he? John, there he is. See, John's a superstar in this crowd. The head of NASA, Charlie Bolden, along with 11 of his fellow astronauts. Mae Jemison, the first African-American woman in space, is here. We've got Bill Nye, the science guy. We've got the Mythbusters in the house. But the most important thing we have here, in addition to this guy, is the young people who are here. Young people from across the country who are already focused on some of the greatest mysteries of the universe. And I'm going to begin with a quick story. A long time ago, in a galaxy far, far away, actually it was in Brooklyn, a 14-year-old asked his parents, "What are the stars?" His parents replied, "They're lights in the sky, kid." The answer did not satisfy that young man, so he set out to answer his endless questions about the stars and the planets and the possibilities of extraterrestrial life. And Carl Sagan grew up to become an astronomer who enlarged this country's imagination and sense of wonder about the depths of outer space. We've got some young Americans here tonight with that same kind of adventurous spirit. When Pranav Sivakumar was 6 years old, he found an encyclopedia about famous scientists lying around the house. At least he thinks it was lying around there. Actually, his parents probably were setting it out, hoping he was going to run into it. And he's been fascinated with outer space ever since. For years, every Saturday morning, his parents drove him an hour to an astrophysics lab for Ask a Scientist class. And before long, he teamed up with researchers he met there to study gravitational lensing of quasars. That is not what I was thinking about at his age. Pranav was a global finalist in the Google Science Fair, not once, but twice. So you know he's going to do some important things. Give him a big round of applause. With the help from their coaches, the RCS rocketry champions of Russellville, Alabama. Where are you? You're back there? There you go. Stand up, guys. They built a rocket that flies eggs, well, at least one egg, nearly 1,000 feet into the air and returns to the Earth unbroken in under a minute. They beat hundreds of other teams to take first place in the America and International Rocketry Challenges. We are very proud of you, gentlemen and ladies. Great job. From the time she was young, Phoebe Kinzelman spent nights like tonight on her grandfather's driveway staring at the stars through his telescope. She spent a summer at space camp at NASA's Johnson Space Center, and her dream is to become an astronaut. I think she speaks for many of us when she says that one of her favorite Instagram accounts is Scott Kelly's. Space is a humbling thing, Phoebe says. You can't get too eager to rule the entire universe, but Phoebe's on her way. Where's Phoebe? Okay, stand up, Phoebe, so everybody can give you a big round of applause. And where's Pranav? Because I was talking about him and I didn't. There you go. Give Pranav a big round of applause. So these are examples of the extraordinary young people that we have here today. Phoebe's given pretty wise advice for a 17-year-old. Young people like Phoebe should encourage all of us to help our young people set their sights as high as they want. We need teachers to light a spark of curiosity in young minds, and we've got some outstanding teachers here today. We need parents to leave encyclopedias of famous scientists lying around the house, or help turn a bedroom into an ideas laboratory. We need to inspire more young people to ask about the stars and begin that lifetime quest to become the next great scientist or inventor or engineer or astronaut. And we have to watch for and cultivate and encourage those glimmers of curiosity and possibility, not suppress them, not squelch them, because not only are the young people's futures at stake, but our own is at stake. That's one of the reasons that my administration's worked so hard to encourage kids to enter STEM fields, especially young women who are too often underrepresented in these fields. We're halfway. We are halfway to my goal of training 100,000 new STEM teachers by the end of the decade. We're on track to connect 99% of our students to high-speed internet before the end of the decade. And over the past 6 years, our Educate to Innovate campaign has raised $1 billion to support STEM programs nationwide, including 80 other astronomy nights happening right now all across the country. So tonight I'm proud to announce new commitments by cities and organizations all over the country to expose even more students and their parents to STEM education. Bayer is launching a national effort to help 100,000 American parents and children work on science and engineering projects together. More than 300 foundations, museums, libraries, and schools across the country are partnering to bring hands-on science programming to students who don't have it. 8 observatories in Hawaii will offer all of the residents of that state free guided tours. They didn't do that when I was in high school. Wish we had thought that up earlier. But these are just a few examples of the work that's being done all across the country, and I hope that more are going to follow the leads of these outstanding organizations, because that's how we're going to make sure our next generation of explorers take us even farther than we're going today. A few hours ago I got a chance to talk to the astronauts up on the International Space Station, where Scott Kelly is living for an entire year. Last month, NASA found water flowing on Mars. Earlier this year, we mapped Pluto in high resolution. In recent years, we've discovered the first Earth-sized planet orbiting a star in a distant galaxy, and we've even slipped the outermost grasp of our solar system with Voyager 1, the first human-made object to venture into interstellar space. In 2017, with the help of American space companies, our astronauts will once again launch to space directly from American soil. And today, NASA is developing the capabilities to send humans to Mars in the 2030s. That means that some of the young people who are here tonight might be working on that project. Some of you might be on your way to Mars. America can do anything. We just got to keep on encouraging every new generation to explore and invent and create and discover. We got to keep encouraging some young kid in Brooklyn or a budding rocket scientist in Alabama or that young girl who's dreaming to become an astronaut. Because as long as young people, like so many of you who are here tonight, keep seeking answers to the great questions, America can do anything. Which is why I'm so excited to have you all tonight. You make me feel hopeful about our future, because I know that you're not satisfied with being home to the last great discovery. You want to be home to the next great discovery. And when I look out in the faces of these young people, I am absolutely confident that there are new frontiers that we're going to be busting through in my lifetime and beyond. So thank you for that. You make me excited and you make me inspired. So enough talk. Let's have some fun with this telescope. It looks pretty big. My understanding is that we've got another young lady, Sophie. We need you to come up here and help me with this telescope, because I don't know what I'm doing. Where are you? Where are you? Save me. Here we go. Okay. I don't want to break it. How are you?
I'm good.
I'm very proud of you. Let's grab a mic here.
Okay.
All right. Introduce yourself.
Okay. Hello, I'm Sofia Alvarez, and I'm a student at Brooklyn International High School, and I'm from Paraguay.
Well, it's great to see you, Sophie. So the what are we going to do with this big telescope here?
Well, we're gonna see the moon.
Oh, well, let's do that.
Okay.
I see it there, but
Yeah.
you think I'm going to get a better view through this this big telescope?
Probably.
You think so?
Yeah.
Okay. So is it already set up for me?
Oh yes. So I just wanted to tell you more about it.
Please
how it
do.
works. Yeah. So these are reflective telescope. So it has 3 parts. There are 2 mirrors.
Okay.
And one of them right now is capturing the light of the moon, and then the other mirror is just making it focus. And then there is an eyepiece lens, which right now is making it magnifying the image of the moon, and that's how you're gonna be able to see the moon like it's right in front of you. So do you
Okay.
wanna
Should I
try
just
it?
go ahead and try it?
Yes.
Okay.
Oh, yes.
Does it matter which eye?
It's the one you see the best
teasing.
with.
All right. Wow.
So right now, what you're seeing, it's they're the black smooth parts, the dark smooth parts. They're called Maria or seas, and they're lava flows. And they're the craters. They are the result of heavy bombardments with other gigantic space stuff with the moon.
Is space stuff a scientific term?
Yes, I think so.
Can I just say this looks spectacular?
It does.
You guys are going to get a chance to see through this, but as good as it looks up there, it sure looks better here. Now, the interesting thing is the image is inverted.
It is?
Yeah, it is. See, if you look up,
Yes.
the right side, my right side, is lit up, but if you look through the telescope, it's the left side that's lit up.
Well, it has a mirror. It's a reflective one. It's like that's what.
I was just trying to make a point
Yes. Yes.
about optics. Well, this is spectacular. So, Sophie, what year are you in school?
I'm sorry.
What year are you in school? What
I'm a
grade?
senior at high
You're a
school.
senior.
Yeah.
So, what do you want to do next year?
Well, I want to follow photography.
Uh-huh.
I'm also interested in Korean studies, and I also like astronomy. So I want to do something with those 3.
Wow.
If possible. If possible.
Anything's possible with you.
Yeah.
You're a spectacular young lady. Give Sophie a big round of applause.
Thank you.
All right, everybody. We are setting you loose. We've got some incredible exhibits all over the place. Not just this telescope, but I know that we've got a mini planetarium and virtual reality and real reality. And so there's all kinds of good stuff. I hope you guys have a wonderful time tonight. And I hope that all of you are inspired the way I am by science and by space. All right? Thank you, everybody.
So I think that's it. Should we open
Yeah,
up for
that's
questions?
basically the end. I mean, we wanted to show you the speech because I think that it shows what was the motivation behind this event, and also he has fun with the event, which it was very cool to see.
All right, let's give him a big hand, folks.
So are there any questions?
Who has questions? So go ahead, Peter.
Would you say it's accurate to say that science started with astronomy? Would you say that that was the beginning of scientific process?
It's been said that astronomy is the oldest science.
Yeah. So somebody once said that if there are intelligent beings on Venus, they wouldn't be scientists because they couldn't see the heavens through the clouds. So that's what sparked science here on Earth.
Okay. Other questions?
I had a question about, has anyone ever made a telescope on one of those searchlights? The searchlights at night, they're out there putting a light on it. How about using the parabolic mirrors inside that and building a telescope around it?
The number of people who have done that, a guy, Turner Bainey, the astronomer at Woodstock Theological Seminary, did a major research in that. So I think it's still alive.
Did it work?
What?
Did it work?
Yeah.
That's kind of my project.
My understanding is that those probably wouldn't be the perfect mirrors for astronomy. You'd probably want to design one that's...
Put your own mirrors in, yeah.
What's the service life of Hubble today?
So the question was, what is the service life of Hubble? That's a really good question. It was initially designed to be a 15-year mission, and we're in our 26th year. So, to some extent, we're maybe on borrowed time, but, with 6 space shuttle missions, including the launch, to repair it and replace parts, it's operating flawlessly right now. I mean, we're at the height of our powers right now. It's amazing. It's a better observatory than it was in the 1990s for sure. But it is like an old car. I mean, it's not going to last forever, but it's interesting. Like, engineers do modeling, how many cycles certain parts can take before they're going to fail. And it looks pretty good. I mean, nobody can really pick a date, but we always wanted it to last as long, to have some overlap with the James Webb Space Telescope, because they're really not the same telescope. They call Webb the successor to Hubble, but they're very different. They're very complementary. An optical Hubble and an infrared Webb operating at the same time would be very powerful. But even that seems like almost a little too modest. I think a lot of people are kind of assuming that we could easily get several more years. Who knows, maybe even 10. It's hard to say, but there's a lot of optimism right now about how long Hubble's going to last.
Okay, front row here.
Excuse me. How were the kids chosen who got to attend this function?
We asked that question and we didn't get a particular answer, but I mean, they were proposed, I think they were proposed by other groups of people as possible candidates, and from those they selected them. But I think they asked around probably to NASA and other groups who will be a good candidate to attend.
So it's the associated question, how many were there? How many, there were the presenters, which there are obviously plenty of those, but how many attendees were there as well?
I heard that there was about 300 attendees and they said over 100 were students. But they said from all over the country, and they said from various organizations. They were nominated by various organizations. And what they told me also was that when the White House announced this event back in August, they said, organize your own events, tell us about them, tell us what you're doing in astronomy education. And what I learned was that some students wrote in about what they were doing, and they were invited that way as well.
What was the age range of the kids?
It was mostly middle school and high school.
Excuse me?
Middle school and high school mostly.
Okay, and I see one over here. You have another question?
The Hubble, it's had some damage with things kind of hitting it. What's the probability of it surviving things like that in the future? Can it get out of its own way?
Yeah, so the question was, things have hit Hubble, and that's true. When they there's the kind of tinfoil wrapper around it and the other components. There's like little micrometeoroids that hit it. Obviously nothing that's done any catastrophic damage. And so there are models for like all this debris, natural and artificial debris that, but again, here we are in year 26 and nothing has hit the telescope that's caused catastrophic damage. It's not to say it couldn't happen, but it's not something that there's a lot of sleep over.
It's safe, we're pretty safe.
Well, NASA tracks tens of thousands of pieces of what we commonly call space junk. I'm sure NASA has a technical term for it that's not space junk, but they track it, and a lot of it is up above. We're in low Earth orbit with Hubble. A lot of it is up in geosynchronous orbit, etc. So, you know, space is really, really big. Despite what the movie Gravity might make you think, space is really, really big up there.
Yeah, the Department of Defense tracks all the debris that is in space, and he said it's much lower than we are with Hubble.
Okay.
Who was the main force behind Astronomy Night? I mean, was it more Michelle than the president, or?
Yeah, I think, so I remember in 2009, it seemed clear that it was Michelle Obama's idea. But even then, both times, the Office of Science and Technology Policy, which advises the president, John Holdren is the chief science advisor. His office was clearly organizing it, but also NASA headquarters and Goddard Space Flight Center was also involved. But then the other groups, so we were one of, I think, 3 groups. One was NOAO in Arizona, and then Carnegie Observatories, I think, were the 3 groups. So, but it seemed like the Office of Science and Technology Policy was really organizing things.
Yeah, and just to add, 2009 was the International Year of Astronomy, so I think the idea of the Star Party was proposed then as part of the International Year of Astronomy. So my question was the same as yours, what prompted us to do it again this time? And the answer I got when I asked was that they wanted to, again, promote astronomy and STEM fields in education and make it exciting among students.
Okay, any last questions? On the ground, don't see any. All right, so we'll give our speakers a hand one more time. But hold on a second. But we are going across the street to the telescope. If you would like to go look through a telescope, not one of theirs, but the one across the street, please meet down here. Next month, telescopes in Chile. Please join us. I know it'll be cold in February, but you made it out tonight. Make it out then. One more hand for our 3 speakers.